Hello everyone, I'm Afreen Fatima. This regarding lesson number, this is video 2. I want everybody got it?
Door code. Door code.
Code
Right here.
is right here.
There you go.
SSQ ECU. Okay, it's good.
All right, you good?
Yeah, we can
All
continue.
right, so go ahead. All right.
What do you notice and what do you wonder? Just look at the numbers and you can enter and we can see the. Everybody is doing it?
Did you calculate your answer?
So what do you notice and what do you wonder?
Yeah.
So, did you enter it? Okay. So everybody is there.
Okay, you need to calculate. You?
Kenneth, did you enter?
Yeah.
Okay.
Okay. What do you know? What do you know? Pay attention.
What is he saying? Yeah, he's been absent for a while. Yeah. Oh.
So he was waiting for the bus to pick him up at home. ¿Dónde tú vives? ¿Dónde te mudaste? ¿Lejos de aquí? ¿Ah? Okay, so what do you notice? What is that? 0, 0, 116?
What?
Yeah, just want to make sure like what's the next thing we can do. Shall we go for the next one or? Okay.
Increase the Y.
Uh-huh.
Mm-hmm.
Yes, so the X and the Y values are both
So
increasing.
increasing, right?
Muhammad,
What did you know, sir?
Yes?
answer the question.
What do
You're
you
not
notice?
even paying attention. We moving on. No snack for you today. Rodney, what do you notice? What do you wonder? X and Y increasing. Kenneth, what do you notice?
They are
Perfect.
increasing? Good.
Ezra, what do you notice? What do you wonder?
Increasing.
Increasing. Does anybody wonder what these numbers represent? We just see numbers. Do we know what they stand for? We don't. Noah, what do you notice? What do you wonder?
That the first 1, 16, and 24 is multiplied by 4.
Okay, perfect. All right. Arlette, you want to answer? What do you notice? What do you wonder about this table?
Both X and Y are increasing.
Good. Foster, what about you? What do you notice about this table?
That's not
Huh?
quite. That's
Okay, all right. Okay, perfect. All right, so everybody answered the question. So most of you all said that you noticed that the X values and the Y values are increasing. Very good, very good. All right, so for today, read what it says for me, Rodney, for the first objective. Perfect. Muhammad, read the second one.
The spin.
I can use tables, graphs, and equations to represent the height of a formula and garbage.
Thank you, sir. Good job. Falling from the sky. What falls from the sky? A lot of things. All right. So, Ezra, read what it says. Let's reason about the values and some data and build a model. What does the first bullet say?
First, we will analyze the scenario as a classroom.
Good job. Noah, read the second one.
Next, you'll have to answer some questions about the scenario and create equations to model data.
Perfect. Foster, read the last bullet. Wonderful. Good job, everybody. All right. So here we go. Let's read this scenario. It says a rock is dropped from the top of the floor of a 500-foot tall building. A camera captures the distance the rock traveled in feet after each second. It says write down possible mathematical questions about the situation. So, I want you guys to go ahead and think about some questions you could ask from this situation. Okay? All right. Can you type on your screen? Can everybody type on your screen? Yes or no? Can everybody type on your screen? Yes or no?
Yes. You can
Yes,
type
all right.
it? Yes.
All right, so go ahead and answer. What is a possible mathematical question about the situation? So so a mathematical question is to be how fast was the rock traveling? When did the rock hit the ground? So type in some questions. I want everybody to answer some questions. Muhammad, what are you doing? I don't see you doing anything.
Wait, answer some question or ask them?
It says write down possible mathematical questions about the situation.
Oh.
So type them on your screen. Okay?
What do you see? Just write it down. You're writing down? Did you write it down, Mohammed? No? What happened? You didn't write it? Yeah, you're doing it, right? Right? You're doing? Okay. Yeah, everybody is writing down. That's good. Everybody is writing down. That's nice.
Where do you even buy all this stuff?
The men's store. I went to go get a necktie in the men's store that I went to at.
So what you notice, just write it down
A
there.
couple of them. I bought like 3 of them. Muhammad, give me a mathematical question that you would ask about this rock. How about this? Here's something you guys want to write down. How fast was the rock traveling? Type that down. How fast was the rock traveling? Write
Just
that down.
Yeah, write it down how fast it is.
How fast? Okay.
Here you can see how fast it can go.
So you
The
can
rock.
say what was the speed of the
The
rock?
rock, how fast it is going. The speed of the rock. Even though it's not physics, it's a math question.
Okay. What's another question that we can ask about this situation?
How the building,
Huh?
how tall is this building?
Oh, we know how tall the building is. How
Yeah.
tall is the building?
Good morning, everyone. This is lesson plan for standard 1, 2, and 3. And here in this, we are doing lesson plan quadratic. And here we'll see when we are doing the quadratic equation algebra 1 special ed, and this is for grade 9. Topic would be introduction to quadratic equation, and in this, like, our class would be like 45 to 60 minutes, but I'm going to compress it for just 20 minutes in this. And this is for special ed teacher and IEP 504 and ASD. The standard task more than standard learning and learners and learning. Standard 1 would be learning development, and standard 2 will be learning the differences, and the standard 3 would be learning environment. So what is the learning objectives? By the end of the lesson, students will be able to identify a quadratic equation in standard form. What is standard form? I'm going to explain it in the lesson. Ax squared plus bx plus c equals to 0. That is the standard form. They will recognize the difference between linear and the quadratic. And this we use a visual model like a table, graph, or pattern to understand how quadratics would be, how the curve would be. Like solve a simple quadratic of the form like x square equals to k using square root. And in this, where we are using three standard, it is addressed over here. Standard, how it is addressed in this lesson. Because focus, we are using these three standards: learning development, learner development, learning differences, and learning environment. So what is learner development? This uses concrete visual symbolic progression, builds on the prior knowledge of linear equation, supports cognitive development through scaffolding. And learning differences provide multiple means of representation. It's like a visuals, manipulatives, like color coding is used so that students can identify those, and offer sentence frames like guided notes. It is chunked into the task, accommodates IEP 504 needs. When we are talking about learning environment, this is like a predictable routine, clear expectation, visual schedule, positive reinforcement, sensory friendly pacing, opportunities for movements and choice. And next, we are talking about what materials we're going to use it: whiteboards or digital slides, color coded equation cards, graph showing linear versus quadratic curves, and manipulative like tiles or digital algebra tiles, guided notes, and we are using fill in the blanks, calculator, and visual timers. So lesson sequence starts with the warm up 5 minutes. We give 5 minutes to the students. The goal is to activate prior knowledge. Whatever the prior knowledge they have, they will practice in the warm up. So students sort cards into linear versus not linear. So include one quadratic example to speak curiosity, and provide sentences frames like I think this is linear because this one is different because, so they will understand that way. So the standard address would be, the standard one will built on prior knowledge. Standard 2 supports diverse learners with visuals and sentence frames. And standard 3 would be predictable warm up routine, and then continues with the introduction to the quadratics. This will be like a 10 minutes. So teacher explanation, simple and clear language. And it will be chunked down, and a quadratic equation has x square term. That's what makes it special. Showing the form, here you could see ax square plus bx plus c equals to 0, and all we will be using color coded, like ax square we can use red color, bx can be in blue color, and c in green. So that visual comparison, showing a linear graph, it's like a straight line, and quadratic graph would be like a u shape this way, opening upper side. And we'll ask the student what they notice, what do you notice. And then the guided practice would be given like a 15 minutes. You could see here the tabular form, x values and y values. Students work with the teacher to identify quadratics. Activity 1 would be finding the quadratic, like students circle the x squared terms in each equation. Activity 2 will be visual pattern. So does this look like a straight line, or what shape do you think this makes? Then independent practice. They are given 10 minutes. Students complete a short worksheet with three equations to identify as a quadratic or not. Two simple square root problems, one graph to label as a linear or quadratic. Then differentiation. Students with ASD may use a visual checklist. Students with the IEPs may receive reduced problem or extended time. Students with 504 plans may use calculator or notes. And standard addressed. Standard 2, learning differences supported. Standard 3, calm, structured, independent work time. So then it will be, they are given the exit ticket, 5 minutes, like a quadratic equation has blank term, quadratic graphs looks like a blank, or solve x square equals to 4. Assessments would be there, observation during guided practice, independent practice worksheet, exit ticket, informal checks for understanding. Either they do thumbs up or thumbs down, and they show the whiteboards, and accommodation and modifications. And for IEP students, chunked instructions, visual supports, reduced workload, extended time, manipulatives, repetition, and modeling. For 504 students, calculators, preferential seating, copies of notes, breaks as needed. For ASD students, visual schedule, clear literature language, predictable transition, sensory friendly options, choice board for activities. So, this was the lesson plan, and this is based on learning, learner development, learning differences, and learning environment. Thank you so much.
You want to write on it? Yeah. Okay, perfect. All right, so what you do is, so you already on it.
This is
Oh,
This is for the one.
how you feel. I know how it goes.
And how to go to
all right, so
review. So from there we go to.
let's move to review. So everybody got that one correct? All right, so this one says, what is the greatest number of arrangements Tiana can put together if she wants to have 30 roses left? If she wants to have 30 roses left, okay, how many arrangements can she have? So look at your graph. So your number of arrangements are here. Your number of roses are here. So if she wants to have 30 roses left, how many can she, what's the answer going to be? Okay. Who's got an answer?
What is the greatest number of arrangements of geometry put together is
So what you got, Robin?
5.
Five, okay. And what do you have, Elias? What you got, Reed?
I got 5.
Everybody got five.
Yeah.
So look
Yes.
where we are. So if this is 30 rows, 30 rows is left, we go over and down and we get what? 5. Very good. So we have 5 arrangements. Excellent. So that should be the correct answer. Okay? All right.
I got it registered.
Thank you, Muhammad. All right, Muhammad, do the next one.
Okay.
So it says, how many pies does Kendall need to sell in order to have just $500 left to raise? All right, so I want you guys to go ahead and look at that one. Foster, you got an answer for me?
How many pies does Kendall need to sell?
So how many pies you need to sell, Ezra? Give me a number. In order to have how much money left? So what number are we looking for? We're looking for what?
90.
No, so we go to what? $500, and we're gonna go all the way over until we look down and we see our number. Rodney, what you got?
100.
100 what?
100 pies.
Perfect. Does
100
everybody
pies.
see how we did that? Does everybody see how we did that?
Yep.
So go over to your money and then go across, and your answer should be 100 pounds. Very good. Excellent. All right, we're gonna do a few more together, and then after that, I'm gonna let you practice on your own. Okay? No, right now.
No,
go
no,
ahead.
right now we are practicing this one, then we will have to. So after 5 hours of writing, how many pages will parents have left to write? So after 5 hours of writing, how many pages will parents have left to write? You can see that here number of pages are there and hours spent writing.
Hello everyone. In this I'm going to discuss in task standard 3 learning environment. My name is Afreen, and in this reflection I will discuss the importance of creating positive learning environment based on task standard 3, which focus on supporting collaboration, engagement and student motivation in the classroom. A strong learning environment is essential for student success. Students learn best when they feel safe, respected, and encouraged to participate. As a teacher, my goal is to create a classroom where students feel comfortable sharing their ideas, asking questions, learning from their mistakes. One important strategy for building a positive learning environment is encouraging students' collaboration. When students work together in pairs or small groups, they can share different ideas, approaches to solve problems, help students develop communication skills, deeper understanding of mathematical concepts. Another important factor is active student engagement. Teacher can use interactive strategies such as questioning, discussion, hands-on activities to keep students involved in the lesson. In mathematics, for example, students may work with graphs, tables, and real-world problems to understand how concepts apply to everyday situations. A supportive classroom environment also promotes students' motivation and confidence. When teachers provide positive feedback and recognize student efforts, students are more likely to stay motivated and continue trying even when the material is challenging. Encouraging a growth mindset helps students understand that mistakes are a part of the learning process. Additionally, teachers must consider individual learning preferences. Some students learn best through visual examples, while other benefits from the discussion or step-by-step explanation. By using a variety of teaching strategies, teacher can ensure that students have opportunities to success. So in conclusion, creating a positive and inclusive learning environment helps students feel valued, engaged, and motivated. By encouraging collaboration, providing supportive feedback, and using diverse instructional strategies, teacher can support student learning and help all students reach their full potential. Thank you so much.